Afternoon, Fancy Meat Computers. Am I in the wrong class? Do you guys have a midterm or something? I'm asking like the one person who's here. Yeah. Okay, I got 6 viewers, according to that. Oh, it's just the chat wasn't... Okay. Yeah. Midterm at 6:30. Oh, that's plenty of time! 2P04. Yeah. Anatomy at 12, and then statics at 6:30. Okay, Jack has you beat. If you do well on it, you won't have to do the exam. Well, how's that for increasing the pressure on you, eh? So, everybody enjoying the snow in November, which is unusual in Hamilton, but not unusual in other parts of Canada. I remember when I lived in Alberta, when I was but a wee child, we always had to build a snowsuit into the Halloween costume. I live several hours north of here, and I was surprised that it took so long to snow. Yeah, it's supposed to be a bad winter, though. This is what I heard, is that it's supposed to be, like, bigger, like, oscillations in temperature with, like, a few big thaws, but, like, a few real good deep freezes as well, and just, like, a higher average level of precipitation. This is like the most Canadian conversation. It's like, if any of you are not Canadians, you should know that the national pastime of Canadians is complaining about the weather. Oof. gross. Okay. Well, I think we can get started. The Canadian pastime is general snow removal. Yeah. Oh my god, I need... I gotta get on that. I gotta get some new snow shovels, because, like, I wore through my old ones. Like, gotta buy, like... I'm thinking of buying metal ones this time, so they don't wear through quite so quickly. Stupid, cheap, plastic snow shovels. I have to say, though, the Big Scoop is like... I don't know if you guys have a Big Scoop, but you gotta get a Big Scoop. It's the only way to, like, manageably deal with the snow plow blocking the end of your driveway. Yep. Well, and you know what the funny thing is? Like, people who live in Ontario, like, particularly Southern Ontario, don't really have a lot to complain about, you know, especially people who live in, like, the Golden Horseshoe area. Like, we really don't have a lot to complain about. They get a way more snow down in, like, London. And even, like, if you want snowfall, try the Maritimes. Like, jeez. Yeah. This is the first time I've heard of someone shoveling so much that their shovel wore down. Oh, yeah, it's, well, you see, the thing is, we got a, yeah. So, my property is a corner lot. So, I've got the sidewalk wrapping all the way around the corner. Got a double-wide driveway that's quite deep. Plus... the next door neighbor is like a 90-year-old woman who is like, you know, like the sweetest lady in the world. And since I'm living next to her, you know, we typically do hers as well. Sometimes she hires it out, but, you know, often we'll just do it. And, you know, so on those days, it's like triple wide driveway plus, like, so, you know, we're doing like half the block. So yeah, we wore down our shovels. I don't know if she's just gonna hire it out, though. I don't know why I bother doing it, you know. If, like, why would I do the work of people who are getting paid to do it? They're gonna make their money anyway, right? They might as well work for it. Save me the effort. But yeah. Anyway, so anyway, we were talking about Makefiles, and we had just gotten into testing here. So, right. Time for a snow mower. Snow mower. Do you mean snow blower? You can't be mixing up your blowers with your mowers there. That just don't make no sense at all. Should get the gasoline-powered ones. I mean... I should, but at the same time, like... Especially with this damn pandemic they've got on, you know? It's like, I have a hard enough time getting physical activity. So, you know, it's better for me to shovel my own snow manually. It's one of the few, you know, sort of exercises I get, you know? No, use the lawnmower with the bag to suck up all the snow. Somehow I think that would probably not work very well. Yeah, okay. So we were, I was showing you some very cool stuff about how you can capture output, right? So we had this output file output.txt, right? So let me just modify sums.c and kind of show you how testing works. So if I have sums.c and I modify it so that it's wrong, right? Compile that. There we go. If I move output.txt to did I just, there we go, just realloc the snow with dynamic memory allocation. Yeah, the problem is, like, if you're out east, you end up with an out of lawn error or an out of lawn exception. Make deer testing. Right. Move output.text to testing slash output.text. There we go. Oh, MV. There we go. And then when we run this and capture the output, so run top, capture output to fresh, let's say testing slash fresh.txt. There we go. We go into testing, and if we diff fresh.txt with output.txt, you can see that the version fresh outputs 2 plus 2 equals 5, whereas we all know that 2 plus 2 equals 4, but that is caught, like, that is in the output file, right? Joke's on fire today. Yes, free snow. Yeah, I mean, I tried that one year. I put a sign out that said free snow. I had no takers. So, so there you go, right? So if there are any differences between what the thing you expect to get and the thing you actually get are, then they'll show up when you diff them, right? So you can actually, so that's a sequence of commands, right? We can actually put that sequence of commands in the makefile itself, which is kind of fun and cool. We're going to do that now. Beep, bop, doop. So if I want to add a new phony target here called test, the first thing I do is I invoke top, capture the output, and store it in testing slash, what did I call it? Fresh.txt. I didn't call it that for any particular reason. Good. That's command number 1. Command number 2 is diff testing slash fresh.txt, and then testing slash output.txt. And then if we put test into our all phony target, right? Then when we execute this, there you go. We can automate the testing, right? So if that is the case, then when we modify sums.c to correct the error that we made, right? All we have to do is type make, bing, bang, boom. Not only does it recompile everything, it compiles it, executes it, and tests it, tells us that there are no errors. Ta-ra! So I just want to dwell very briefly on this line right here. So makefile 22 test error 1. So this is the way that Linux and Unix interact with its own programs, essentially. The idea is programs have exit codes. So when you have a program that runs, it will return an integer. And you'll have seen this a lot in C so far, right? The return value from main, you know how a lot of the time we do return 0 at the end of the main function? That is returning 0 as an exit status to the operating system, right? 0 means everything went correctly. Any non-zero exit status means that things did not go exactly correctly. So, we can test this in bash scripting. I know we only did bash scripting very briefly at the beginning of the semester in tutorial, so probably nobody remembers it. But with bash scripting, if you use the special variable $?, that gives you what the return value was of the last program that was executed. So let me just finish this, and I'll answer your question. So essentially, this what we can do. So rather than have the this stuff occur in the makefile where we can't use if statements, right? We can create a new file, create a shell script. So we'll create testing touch testing dot shell chmod plus executable permission to testing dot sh. That'll turn it green. There you go. That means it's executable. Get it testing dot sh. So just ooh, that's gross. It's also the wrong type of quote. There we go. Good. So we run, then we can just copy in the two lines from the makefile. Get it. Makefile. So the question is, just wondering, how are we going to be tested on makefiles? Are we even being tested on it, or is it's just something we should learn? So, I'll probably ask you. There will probably be a question on the exam. Write me a makefile. It's probably not going to integrate it probably wouldn't integrate this testing stuff. It'd probably just be like, do you know how to set something up for compilation? Because that's actually a testable thing according to the thing. I'm very confused as to how that if statement works. We'll come back to it. But I'm just going to grab this stuff. There we go. Put that in. And then instead, I'm going to execute testing.sh. So, very briefly, this is the syntax for if statements. So if statement starts here, ends with fi, so it's like if backwards. This is the exit status of the last program to execute, which will in this case be diff. -eq tests equality with the literal 0. So -eq is the equivalent of double equals. And in Bash, it's like stuff that's in square braces gets automatically routed to a program which performs these tests, but that you don't really need to know about that. It's just like, just copy this form and you'll be golden. So that all being the case, if we there we go. So everything is saved. Everything is saved. So if I make now, well, let's touch sums.c. Make. There we go. Oh, unexpected operator. Uh-oh. Did I mess this up? Did I mess this up? I might have messed it up. Let me just take a brief moment. Okay. So, Stack Overflow recommends doing... Oh, maybe I'm just missing a semicolon. Maybe I'm just missing a semicolon? Maybe. Let's see. So right now I'm just testing the testing script, which is kind of fun. All right, so that's testing succeeded. Now the question is, if we modify sums.c, reintroduce the old error, which we know should modify things. Let's see if that... Testing failed. Yes, good. All right, so that works. That's Bash scripting for you. It's basically like try different things until one of them works. So yeah, anyway. So the point of what I'm doing here is like, I'm trying to show you that you can integrate a testing routine into the compilation routine so that the output is checked every time, like it's integrated into the very compilation itself. So you have to do nothing. You don't have to manually execute the script. You don't have to manually diff it against the expected results. You can, like, all that is Bash commands. You can hook up makefiles and shell scripts to do all of that for you every time automatically. Bing, bang, boom. And there you go. If I remove the clean routine from that, I think... let me just see here. Yeah. Rerunning it when it's already been generated just runs the testing script. But yeah. Let's see. Good. Output comparison using diff is a great way to is great for automated black box testing. However, many, even most of the properties we may wish to test are internal to the program. The assert function, contained in assert.h, allows us to perform testing within a C program. If the condition fails, assert invokes the abort function, which immediately terminates the program and returns a non-zero exit code. Additionally, assert reports to standard error the expression which failed the test, the line number that failed assertion was on, and which file the assertion was in. So, for example, let's say in top.c, we know that this guy should equal 4, right? So we can include assert.h. This is the same way that we, this is important to the auto grading, by the way. This is one of the mechanisms that the auto grading takes place using. So we assert that the sum of 2 and 2 is equal to 4, right? I think that error is still in there. Yes, it is. So, in that case, if we make, you can see, well, like this guy still works, but when we execute top, we get top.c line 7 main, so it gives you the function the assertion failed in. Assertion this failed, and then it aborts, core dumped. So you can perform that sort of testing within the file itself as well, which can be useful. Again, this is essentially the way that the autograder works that we've been using for the assignments and such. Is it provides an assertion, and if you fail the assertion, basically our autograding script watches to see if anything that relates to your program executing results in a non-zero exit status, right? So basically, if you return 1 from main in your assignment, you'll get 0. So don't do that. You'll have to come to us later for the grades. But essentially, you know, we compile your program with GCC. If that fails, GCC returns a non-zero exit status, which we can catch and say you don't get any marks because it doesn't even compile. And in our estimation, a program that does not compile is not worth any marks at all. Because you should at least, like, even if you were to submit nothing, that nothing would still compile, right? So A, like that happens. B, the assertion, like, if the assertion fails, then you'll also get a non-zero exit status when running the program itself. We can catch that and give you zip. Basically, if your program runs through all of the assertions without producing a non-zero exit status, then you get the marks and you don't otherwise. Is that why the main function is deleted when marking? The main function is deleted when marking because that's the simplest way for us to inject the assertions into your code. Essentially, so basically there are 2 main ways of doing it, right? One is to rely on the student to be able to, like, correctly format print statements that are the print statements that we expect you to produce, right? Which is like, basically, like if we did diff testing with your assignments, it would be vulnerable to you not formatting the, like you having extra print statements or you not formatting the print statements the way they're expected to be formatted. So there's like so many things that could throw off a test case, that it's like, that's not a good way to do it for the purposes of grading your assignments. With an assertion-based testing, you can have as many print statements as you want and it won't affect your grade, right? And, you know, the only issue that you run into is, like, how do you inject those assert statements into the student's code? And the easiest solution that we came up with is, you know, it's reasonably easy to, when we're, like, if we manipulate your file, like if we load your file into Python as, like, just a string, we can very easily pick out the main function, right? Just snap it shut, delete it, pull it out, throw in one that we've written in a separate file, and, you know, as long as you've, you know, not changed the function interfaces, which is a much easier thing to not change because we give you the function interfaces, then everything will work out, right? So that's like, asserts for us are a much more stable and reliable way of testing than diff testing. But diff testing can still be very useful. But anyway, so that's just another way of going about testing. So, running. So this is just another example of an assert statement. Basically, if you don't enter the letter X when you pull scanf, then it just it flunks out. Otherwise, it just tells you good job. So if you ran this code, it's like enter the letter X or else, and you entered make me, then you get an assertion failure. So, application, auto-grading. I kind of already talked about this. I'm terrible for, like, jumping ahead of my slides, but... So, this is how the auto-grader works for the assignments. First, a program replaces your main function with one of our own design that calls your function for certain inputs and makes assertions about the outputs it receives. Then we compile your program. Any code that fails to compile is reported as a failed test case. Your code is then executed. If our inserted assertions fail, that test case is considered failed, and a 0 is recorded. If no assertions fail, the test case is passed, and you get however many points that test case was worth. We run several test cases per question. In this manner, we can process each assignment in about 1.5 seconds. So, I can tell you that for the length of the assignments that we give you, a good TA would take probably 15 to 20 minutes to grade an assignment. Like a good TA. A bad TA might take upwards of like 40 minutes to an hour to mark a single assignment, which is ridiculous, of course. So 1.5 seconds versus, you know, even 10 minutes. Basically, we can get the entire class graded in like 5 minutes, which is amazing, right? Absolutely amazing. So this is the power of automated testing. And it is because of the auto grading. Like, so this is like the pedagogical justification for auto grading, because it's like, oh well, you know, to the degree that human beings are no longer looking at your work, are you really being graded fairly? And it's like, well, you're being graded more objectively. I've never failed so fast before. It's like, you fail. But no, by, like, grading is kind of this routine drudgery of the teaching profession. You know, it's like the stuff nobody really wants to do. And even if there are problems with the auto-grading process, it's easy, like it's more time efficient to run the autograder and deal with anything, like deal with the extra scrutiny, than it is to grade by hand and assume there's less scrutiny. It actually, in my experience, it turns out that you spend more time dealing with improperly graded assignments when human beings are grading the assignments than when a computer is, because human beings will not grade consistently, whereas a computer certainly will. And, you know, when you change, like if you have to change the way that that an assignment was graded post fact, you can change it once and rerun it for everyone and then just upload those grades, which is much faster and much better. But yeah, 2 weeks of work is graded in 1.5 seconds. Yes, exactly. So what it does is it frees up the TA's time to be able to spend more time interfacing with you, the student, right? I can, like, take a TA and, like, dedicate him to Piazza, you know, because we have an autograder. I don't have to consume all of his time with marking. I can have him do more useful and interesting things. But yeah. So there you go. So, so we have one more thing, and you're probably going to say, man, if only you had mentioned this sooner. And I think I did actually mention it sooner, but we'll talk about it. So, you may have noticed that the C compiler's errors suck. They aren't as explicit as Python's. This functionality exists, just not in GCC. Static analysis engines are pieces of software which analyze code without executing it. If you have to run the code to analyze it, then it's called dynamic analysis, not static analysis. Are there ways to see why you lost marks on specific assignment questions? In theory, at some point in the future, we will expand our auto-grading software to the point where it will return, like, more interesting and useful feedback about particular questions, but it's just been, you know... we haven't had the time this semester, unfortunately. So, during static analysis, I think they released the test cases for A3, so you can probably try those. Yes, there you go. During static analysis, source code is pre-processed and parsed, but no executable code is generated. Instead, the abstract syntax tree itself is analyzed. Common patterns, which normally indicate bugs or problems, can then be identified and are reported to the user. So, introducing CPP check. To quote the CPP check manual, CPP check is an analysis tool for C, C++ code. It provides unique code analysis to detect bugs and focuses on detecting undefined behavior and dangerous coding constructs. The goal is to detect only real errors in the code and generate as few false positives or wrongly reported warnings as possible. CPP check is designed to analyze your C, C++ code, even if it has non-standard syntax, as is common, for example, in embedded systems projects. So, CPP check. CPP check. Sudo apt install CPP check. There we go. Just gonna install that right there. This is what installation looks like on Linux, by the way. Boom! CPP check. Example usage. There we go. So, essentially, if I have cat bad code let's take a look at badcode.c. So this is, this is code that it contains some bad stuff, like out-of-bounds array access and division by 0. If we run cpp check on badcode.c, you'll get, it'll tell you array accessed at index 10, which is out of bounds. So it'll give you an array index out of bounds error, and it'll do division by 0. But yes, the problem, of course, is that this doesn't catch all errors. This only catches static errors, but that's still better than nothing, right? So I think there was like an expanded error list as well. Yeah, well, anyway. So CPP check. Highly useful tool. So, to install on Debian family things, it's sudo apt-get install cppcheck. On Fedora, it is sudo yum install cppcheck. On Macintosh, it's brew install cppcheck. If you use the Pascal server, it's already installed. If you're on Windows, you can find an installer at sourceforge.net. And those wishing to have CPP check installed directly onto their brains will have to wait for driver support. This may be a dumb question, but what are static errors? So a static error is an error that exists without even having to run your program, right? So syntax errors are static errors, right? Basically, it's an error that can be derived from static analysis. Some errors, you actually have to run the thing. Like, for example, if you're accessing the elements of an array with a variable, you need to actually run the program to see what the value of that variable is anytime you perform that command where you access the index of the array. So if that goes out of bounds, that's a dynamic error, right? However, if you're using a literal there, that's a static error if it's out of bounds, because it's like you don't have to run the program to know that 10 is equal to 10, right? But yeah, good question. So, limitations. So, what CPP check does, it detects common error patterns, it points out stylistic issues, detects when code is dangerous. It can tell you things like out-of-bounds arrays, zero division, useless conditionals, unreachable code, and there's a full listing of the things that it checks here. It checks these for C++ as well as C, but of course C is a subset of C++, so there you go. It has all of these checks. Some of these are only applicable to C++, but yeah. It checks a lot of stuff. Right? So, what it doesn't. CPP check does not detect all bugs. Certainly not. It does not compile your code. It does not detect anything outside of its specified patterns. So it only checks for specific things. It checks for a long list of specific things, but it only checks things that are on its list. And it detects semantic errors that are unrelated to getting the math wrong. So it will not tell you whether you got your question right. Right? It won't tell you, for example, that this is an implementation of insertion sort. It'll just tell you this implementation doesn't have any obvious errors to me. You know, errors which are obvious to me, I don't see any. Right? What it doesn't is replace testing or careful design. CPP checks should be used in addition to testing and careful design, not as a replacement for them. CPP check also tells you the current status of your pension plan. Ba-da-ba-ba-da-ba. Yes. So, there are a lot of options for refining and customizing the analysis. For more information, read the manual. Da-ba-da-bam. But yeah. So, any questions? We have like 5 minutes left, so I can dip into the next topic anyway. Thank you, thank you. I'll be here all week, unfortunately. Ethan's on fire today. If you have a question, you must ask the question. I'm still a little confused on how assertions work. A little bit like an if statement. So, an assertion works like this, right? So, this guy is the same as saying if, sum2 equals, is not equal to 4, then abort. And abort is an actual command that you can actually use. It's the same as that, basically. Except it's like it's that, but then it also provides much more useful, it provides more interesting and useful information that allows you to actually trace back where the assertion actually failed, like where the program aborted, so that you can debug it. Good. There we go. So, let's talk about some more advanced bash commands. This is more like utility stuff that you can use to determine how good your code is. So it continues if the assertion is true, and if false, it exits the function. Not just the function, the whole damn program. It just snaps it shut. The entire executable crashes. It's like a manually induced crash. Yeah. Yeah, if the condition inside of the assertion is true, there's no problem. If it's false, it kills your program. So, let's talk benchmarking. Oh my god, it's actually all right. Okay, I'll give you a brief overview of what we're going to be talking about next time then. So, we're going to be talking about the htop command, which allows you to view the processes that are going on inside of a Linux client, and you can also kill things that way. But you can also view how much memory a process is using this way, so we're going to be talking about that. Because the theme of this topic is, how do I actually find out how much memory I'm using? Or how do I actually figure out how much time I'm using? Right? There's also, we're going to talk about the time command. We're going to talk about profiling using gprof. We're going to talk about coverage testing using gcov. And we're going to talk about Unix file permissions for no particular reason other than that might be interesting to you. Last topic? Yeah. Possibly. Depends on how long it takes, but yeah. Yeah, it's been a fun course, eh? I've enjoyed this course. This is one of my favorite ones to teach. Any questions? Topic 7. Uh-oh. Did I fail to update that, or did I pick the wrong one? I think I failed to update it. Oh, and I might as well say Mectron. Yeah, if we finish this one a little early, I guess I could pull in, like, pipes and filters, which is also very interesting material. Oh, shoot. I forgot to tell you about course evaluations. Gosh darn it. So, course evals. Quickly. So, the course evaluations are the, course evaluation. So, course evaluations! You guys are second years, so you should, or at least second years, so you should know already about the course evaluations. But so the course evaluations are now open. I think they've been open for a week now. And essentially, if we get our response rate over 75%, I will knock 2 marks off the denominator of the midterm. So get those course evaluations in, please. It's of particular importance for sessionals such as myself, because our promotion to like full-time status is based primarily, I think, on the how well we review. So please, 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 if you enjoyed the course, leave me a comment saying you enjoyed the course. If you feel there are some aspects of the course that could be improved, please let me know about those. The more specific the thing is, the more likely it is that I'll be able to actually implement it and improve the course that way. Like, just saying the assignments were hard is like, it's like, okay, you know, that's not really actionable. But to say something like, you know, I felt that there was not enough focus on the Linux stuff, we should do more of that earlier in the semester, it's like, yeah, that's like something specific enough to be actionable, right? Cool. What if you got 100% on the midterm? Then you would get a few bonus marks, wouldn't you? What's the percentage at right now? For some reason, this is the only course I have that I can't see the percentage completions it has. Yeah, I know. That's because I'm a sessional, actually. At least I think it's because I'm a sessional. I think that they like prevent you from seeing they don't report the average percentages for sessionals for whatever reason. I have to manually inquire. So at the end of the week, I'll do a manual inquiry and see how far, what long we got. But yeah. So fill out those course evaluations. Any other questions? How do I see response rates for any class? Statistics? Engineering? There you go. I thought for initially they might still be listing us under like software eng, but I don't think that's the case. Oh my gosh. Aha. MacEng 2 QA4 has quite a high response rate, eh? Hmm. 2Q is bribing you for 90%. Ah, see, I'm nicer. I'm only bribing you for 75. He'll remove your lowest test grade if you do better on the exam. Yeah, I'm not going to do that. Yeah, I don't think I'm going to do that. I don't think people did particularly badly on the test, though, so... Let's see, science. Boy, the science people aren't really responding much except for kinesiology. What? Physics 100%? Get out of town. Must have like 3 people in it. Yeah. I love how they've actually used like the fact like the reds and the blues and all the colors for the various faculties. Wow, that's a pretty high percentage of Mac. Jeez. Come on, we gotta get that other percentage up for us Linux guys. Anywho, I think that'll be it for me for today. Thank you very much for attending class today. We don't have too many of them left, eh? What do we got, like 3 classes left? I should let you know that normally what I do with the last class of the semester is I make it at like a Q&A review session. So if you have any questions from any point in the course of a topic that you'd like reviewed or a question you would like addressed or something like that, bring that to the last lecture of the semester and we will address it. So there you go. Take her easy, folks.